So we know that suppose if we have a plant that is given unlimited sunlight, right? Then it is given unlimited carbon dioxide. It is given unlimited water, and also that it is kept in a warm environment. So all these factors, they are very favorable for the photosynthesis. So this plant will be able to photosynthesize at its maximum rate. However, we know that we have some other plants, or the most plants, they do not have unlimited supplies of raw materials, such as the uppercase. So what happens in these case of plants? Their rate of photosynthesis is limited. It is limited. And that is limited because of any factor that is in shortest supply at any given time. So how can we define a limiting factor? We can say that a limiting factor is any environmental factor that limits the rate of reaction, right? This is how we can define the limiting reactant. Okay. Now we have three main such factors that limit the rate of photosynthesis. What are those three main factors? The first is the temperature, then we have light intensity, and then we have carbon dioxide concentration. Okay. Now, Laiba, could you tell me that why water is not a limiting factor over here? Reason that water is not enlisted in the list of limiting factor. So we say that water is involved in multiple plant processes. And that processes such as transport, it could be a part of cell turgidity as well, right? So it is likely to affect other plant processes before it directly affects the rate of photosynthesis. Is that clear? Now we can see one effect of water availability, that if you have limited water availability, it could result, it will cause the stomata to close. And if the stomata will be closed, then you can say it will be limiting carbon dioxide availability. Is that clear? Now we can carefully see the different limiting factors. Suppose let's take temperature first. So if temperature is the limiting factor, we know as temperature increases, the rate of photosynthesis it also increases, right? So see here at y-axis we have the rate of photosynthesis, while on x-axis we have the temperature, right? So this is how the temperature graph, temperature and photosynthesis graph looks like. Now see this area. What happens here that we say that here increasing rate, we can observe the rate of photosynthesis increasing as the number of collision between the substrate and enzymes increases, right? What happens here at this temperature? we know that this is the optimum temperature. And what happens at this area? At this area, due to increased temperature, the enzymes, they begin to denature. So we can say the rate decreases.
Ma'am,
Yes.
I don't understand this statement in dark.
Now see the other factor, that is so we can also conclude this by saying that as the temperature increases, the rate of photosynthesis increasing increases, and this continues up to a temperature at which enzyme denaturation occurs, after which the rate of photosynthesis decreases. Now moving on to the second limiting factor, that is light intensity. So the higher the light intensity, the faster the rate of photosynthesis is. Okay. Now see here. So this is the graph for rate of photosynthesis and light intensity. So at x-axis we have the light intensity, at y-axis we again have the rate of photosynthesis. So see, at this point, first you can see a slope on this graph, right? At this point, we say some other factor becomes limiting, and here the graph levels off as the rate becomes constant. And at here, at lower temperature, at lower light intensity, the increase in the rate is linear. That means more light intensity and more rate of photosynthesis, right? Here we can see that the rate of photosynthesis and the light intensity. So their relation was linear over here. Now, you can say that here till here, the relationship is linear. It is linear. Now, what happens over here at this end? We can say some other factor that is required for photosynthesis becomes the limiting factor here. And that other factor could be temperature, or it could be carbon dioxide concentration. So we can sum up this by saying that as light intensity increases, so does the rate of photosynthesis. And this can be seen as a linear relationship on a graph. Now, once the graph levels off, as you can see here, from here it starts to level off, right? Another factor, those factors could be either temperature or carbon dioxide concentration. They become the limiting factor. Now then we can have a look at the third limiting factor, that is carbon dioxide concentration. Now see what happens in this case again. As the light intensity, sorry, as here, as the carbon dioxide concentration increases, the rate of photosynthesis also increases, right? You see here at lower concentrations, of carbon dioxide, so you can see the increase in the rate of photosynthesis is linear. You can write this. Okay. Now at this point, some other factor again becomes limiting, and then the graph levels off as the rate becomes constant, right? Here the again the relationship over here was linear. It was linear. Now, while the graph was showing a linear relationship, till then carbon dioxide is a limiting factor. And this trend will continue until some other factor required for photosynthesis it prevents the rate from increasing further, and the new limiting factor could be either temperature or the light intensity. So we can sum this up as carbon dioxide concentration increases, so does the rate of photosynthesis. So this continues until another factors become limiting, right?